So welcome everyone back to our program. My name is Ingrid again. I am the co-chair of March for Science New York City, and something that I don't talk a lot about is that I'm actually also a scientist and chemical engineer myself, which is why I'm super excited for this next segment, talking about decarbonization and what it takes to actually take technologies that make the world more sustainable and implement them into our energy system and make, for a cleaner, healthier planet for everyone. So for this conversation, I'm super excited to be joined by Miguel Modestino, who's one of my colleagues at NYU Tandon, where we're both professors, and Raya Salter, who is the founder of the Energy Justice Law and Policy Center and also a member of the New York State Climate Action Council. So we're going to talk, we're going to keep it casual for the next 12, 15 minutes or so, talking about our work and where, for all of you who are watching at home, how you can plug in and learn more. Hopefully, some of you at home might want to be chemical engineers or lawyers yourselves working on these issues. So maybe we can go and get right into it. So Miguel, we're super excited to start with you, welcoming you back to our stage after we met last year, talking about electrochemistry and some specific decarbonization strategies to the chemical industry. And I think it's been really exciting, at least as an engineering academic myself, to see how our field, from an education as well as research standpoint, is moving towards acknowledging the need for sustainability. And you've recently been named the director of our school's new initiative around sustainable engineering, which I'm super excited to be a part of myself. And I know you're working with this framework that you are looking at to approach these problems, because they, as much as we want to pursue sustainability, it's not a trivial problem, right? And this transition that we often talk about to renewable energies can take a lot of steps to take, from both research and then, as we'll speak about with Raya, to the policy end. So could you explain some of the framework that you've been using to think about these problems?
Yeah, absolutely. And thanks a lot, Ingrid, for inviting me again. And we're also super excited to have you as part of the initiative. For those of you that don't know, Ingrid is an amazing educator. And she's been really helping us come up with the framework to introduce sustainability concepts at the very first entry level of engineering, because we believe that we as engineers play a key role in sustainability, and it doesn't really matter which discipline you go into, you have a role to play to make technologies more sustainable and to help come up with those technologies that we need to solve some of the most pressing challenges that we have in society. So within the Sustainable Engineering Initiative, as I mentioned, we're focusing on education, but we're also focusing on research and translation, and we use a framework that we call AMRAD, where we're really focusing on a different level of priorities of technologies that are required to fight climate change and environmental pollution, starting with the A, which is avoidance, which basically means that we're going to have to try to figure out a way to implement technologies that can allow us to avoid emissions. So, for example, when we think about electricity generation, we have solar cells and windmills that can provide electricity in a way that avoids emission that may come from coal-fired power plants, for example. But as we move towards the transition, we're still going to have a lot of fossil fuel-driven power plants that are emitting into the environment. So next level of priority is mitigation of these emissions. So, for example, if you have a power plant, what we're trying to do is to also help develop technologies that can help us capture that CO2 that comes out of these plants before they mix it into the environment. There's other classes of technologies which take us to the third level of priority, which is remediation, which comes into play for systems in which it's not really possible or feasible with the technologies that we have today to even mitigate the emissions. So, for example, aviation. We don't really have a way to run our planes without emitting CO2, and it's really not feasible to capture the CO2 in the plane in a way that doesn't make it into the environment. So for these type of challenges, we're going to have to remediate those emissions by capturing them, perhaps directly from air. And there's technology that is needed for that. And then the fourth level of priority is adaptation. And this is something that I say four, but it's incredibly important because there are going to be changes to our environment that we're not going to be able to avoid, and that they're coming. And these are changes in which engineering solution can really help us mitigate the biggest damages to our society, our economies, and our infrastructure. And we here at NYU Tandem, we have a team of roughly 20 different engineers from different fields that are looking at this problem from multiple angles, including you, Ingrid, who's really helping us trying to develop these people, because ultimately, we're only 20 people at NYU. Basically, all of the engineering schools in the country and perhaps in the world have different efforts that are trying to help us mitigate these challenges. But ultimately, it's through our students that we educate, that make it into the world, that are going to be ultimately responsible to deploy these technologies. And we're very much aware that technology is not the solution for everything, and there's a big aspect of this that comes from policy. But we as engineers are sort of tasked with this responsibility to really look into technological solutions that can then help us get to those solutions in an easier way and perhaps more economically beneficial way.
Yeah, for sure. I feel like there was so much opportunity there. And I feel like for me, like as a student learning about the climate crisis myself, just from my own experience growing up, I was like in New York and New Jersey, like during Superstorm Sandy. And I think that's really when I started to think about these issues myself. And just that I think it's hard to not feel that sense of climate doom. But as an engineer, it really can be empowering, or even as an advocate or climate activist, thinking about all the opportunities we have to do all the things you just said, Miguel, like really rethink our systems and come back, better, and not just, for the short term, but for the long term. Especially knowing, I feel like something that I personally reckon with is just like the history of the chemical industry in particular. Just our industry really came up with industrialization, right? So played a very large role in perpetuating all of these environmental and public health harms. And it's a challenge because what it takes is like, we built all of our systems on this, and now we really have to transition off. And it's not, again, trivial to, not a trivial problem to address from both from an engineering standpoint from an engineering standpoint. But particularly with the chemical industry, for folks who aren't too familiar, what are some of the challenges that we face in making them more sustainable?
Yeah, the chemical industry, it's an interesting example. It's one of those sectors that is very difficult to decarbonize. And one of the big challenges is the fact that the chemical industry grew sort of out of the oil and gas industry because, early in last century, like we discovered this wonderful fuel and figured out how to extract energy from it without sort of realizing the damage that we were causing to the environment. And at the same time that we had an energy vehicle, we also have feedstocks to make chemicals on the same compound. So pretty much all the petrochemical plants that we build today are somewhat attached to a refinery or close to where we generate petroleum. And we build these two industries sort of together. And more than 90% of the processes that we currently practice in the chemical industry are powered by fossil fuel combustion because of this reason, right? And because of that reason, it's very difficult to come up with technologies that help us to decarbonize them. Because you're going to need...
Make no mistake, the petrochemical industry is one of the biggest drivers of climate change right now, as we speak, in a malignant, aggressive way. And in fact, it is even as this cycle, and there's so much, and this, so much of the chemicals, just the chemical pollution on its own, but this whole, this plastics industry, we have, the bottling industry, we know these things aren't recycled, and the money goes straight from the petrochemical, from the fossil fuel industry to the plastics company, to the ocean, to the climate and beyond. I mean, it's something that needs to be disrupted.
Yeah, no, absolutely, Raya. And when we talk about the Sustainable Engineering Initiative, we make sure to not only talk about climate change, but environmental pollution because of this aspect that you're talking about, right? Perhaps plastic pollution is not something that very directly impacts climate change, or not as much as perhaps CO2 emissions. But it's something that ultimately impacts very substantially the health of our planet. And these are problems that are completely interrelated. So
in some ways, GHG emissions are just a symptom of our overconsumption and waste problem.
Yeah, absolutely. Yeah, and as you mentioned, the chemical industry contributes like almost 10% of the greenhouse gas emissions by itself, right? Like, and most of those chemicals really make it into plastics, and the ones that don't make it into plastics are even worse because they're more toxic and they make it to our water systems, to our soil, to our air.
In fact, there's a recent study that they're finding microplastics in human lungs.
I read that study, and
and also recent studies about chemicals that were actually beyond our ability to cope with or even regulate, because there's been so much unregulated, chemical pollution that we're beyond our ability to even understand what's happening.
Yeah.
It's bad. It's really difficult.
Yeah. I know it's a lot to deal with, but I think
one particular example, which researchers at Tandon are also looking into it. There's some compounds that make it into the water. These are usually referred to as PFCs. They contain fluorine, which are not naturally occurring. And it was only until recently that we were able to measure them at the levels that are currently in the environment to realize the level of the impact. So for many decades, we had just been putting them out there without even realizing that they were just leaching out of our chemical.
That's a perfect example. And then what did we find out? They're forever.
Right. Yeah, because we as chemical engineers made them to last forever, right? Like, because we had a paradigm in even our education system on how to make better materials, make better chemicals that didn't account for sustainability in its way of developing design rules. And this is what we're trying to change. And actually, this is where like Ingrid actually can play a very significant role into helping us change from the very beginning. Like when you come into school and you say, I want to be an engineer, you have to understand these impacts, and not only from the particular technology that you are working on, but on the systems level. What are the implications beyond your own reactor, right?
That's right. And as an advocate, I always want to be encouraging and optimistic in terms of being able to change direction.
Yeah, exactly. Are there any solutions in particular, Miguel, that you've been working on or that you find really promising that maybe folks at home might be interested in looking into?
So I think there are different levels of solutions. So of course, we're at a university, we focus on fairly long-term solutions in the time frame that are needed, like 20, 30 years down the road. So these are far from implementation. So we work on technologies which we call electrochemical technologies, where electricity drives chemical reactions rather than using heat from fossil fuels to drive these chemical reactions. We're also very conscious that there is emissions that come from the electricity production. So we work very closely with electrical engineers to understand what will be the impacts of having chemical processes that run on electricity in a future grid, which hopefully will be dominated by renewable energies, right? So this is one way that we're looking into tackling some of the challenges moving forward by electrifying and decarbonizing electrifying the chemical sector and decarbonizing the electricity sector sort of together. On the shorter term, I think the technological solutions are really retrofits to technologies that are already in place, right? So I talk about some of these reactors that are powered by fossil fuel combustion. They require heat. You can generate heat using electricity and you can electrify in that way. But there are technological challenges that come with it because many of these reactors operate at thousands of degrees Celsius, in which you don't really have electrical conductors that can survive those temperatures. And that's where really technology development at the earlier stage come in, and academics and industrial researchers can come together to try to find some of these technological challenges.
Yeah, oh, so exciting. If you're at home and you're curious about any of these things, we definitely have a video that we did last year with Miguel and another professor, Melissa Park from Columbia University, around more of these technologies that we'll definitely share out. But I think this is exactly, coming into chemical engineering myself, I feel like I was very unaware of the scale of the impacts that our industry had. And I think there is that kind of, again, I mentioned like my own personal, like having to deal with it and how I wanted that to inform my career. But there really is just an abundance of opportunities. And I think with academia really changing its tide with political pressure and everything coming together to really rethink all these systems as they come through. And if you are watching and you're in high school and come study at NYU, you could do it with us, which is super nice. But I do want to turn it to Raya, who can speak more about how we like the quantity and like the scale of this issue that I had mentioned. Raya, I'm going to pull up your slides for you real quick in true March for Science fashion. And one moment, and then feel free to share with us the work that you've been doing.
All right. And I can't tell you, I'm so glad to be here and listening to folks like you, Ingrid, and Miguel talk about these technologies are some of just my favorite things, because really we can't, as you know, as policy folks, we can't we can't march these things forward unless we have this community of academics and folks taking the technology. I personally find it fascinating. So for the viewers, what I'll just go ahead and say as a brief overview is that in New York State, in 2019, we passed a law called the Climate Leadership and Community Protection Act that had some of the strongest requirements for GHG reductions in the country. We were since kind of sort of beat out a little bit by Washington State, but we still have a very progressive climate law. And one of the pieces of the law that's important is that it has to be a just transition. There's a lot of environmental justice, climate justice built into it. But what I wanted to say here, so what we're doing in New York is creating the plan for how New York State will reach these goals by 2050. And we have 2030 goals, 100% zero emissions electricity by 2040, and net zero economy-wide by 2050. So they're what the United Nations says we need to do, but boy, are they big. And so here in this graph, what you see is sort of if we're thinking economy wide for emissions, like what does that actually mean? And on the one side, you see this wheel and it's breaking up our emissions by sector. And I find this interesting, when you look at how big that piece in New York in particular is buildings emissions. And you can see how landfills, waste, transportation, you can really kind of dig in and see what we're actually trying to do in New York State, which is get to this, downward slide of emissions that you see by attacking it sector by sector. Next slide, please. And so this slide illustrates, this is where we are in New York. I know it's a busy slide, and maybe we can make them available for folks after because it's a busy slide. But what we're doing is we've developed what we call three decarbonization pathways. And so, why we couldn't have just picked one, and the scenario 3, the most away from combustion, which I would have liked to see. Controversy, but what we've got are these decarbonization pathways. And so without going deep into any of them, just wanted to illustrate how you see it on the left, that we're really digging in. How can we look at the efficiency in electrification, transit, vehicles, fuels, carbon sequestration and land. And so we really are literally going sector by sector to develop strategies to achieve those overall emission reductions. So that can be my next slide talks about the cost benefit. Maybe very quickly I'll address it. Because I doesn't want to be excited about how much we as advocates, we always know that the cost of inaction is far outweighed by the cost of action. But guess what, in New York State, and again, it's busy because we did it on our multiple scenarios, but we're looking at a really big 90 billion plus benefit in health, in jobs, in many other areas if we make sure we act on climate in this way. So that's what we're doing in New York, and that you can end slideshow. I like
Sounds good. I got you. That was perfect. That was great. And I think, I was super excited to hear about, I'm going to just close PowerPoint on my computer as well, about the CLCPA. I hope I said those letters in the correct order. Okay. Yeah. As an engineer and advocate myself, and it's interesting to see just really how sector by sector, you really have to tackle this problem, right? I think going to Miguel's point earlier about how this is really an interdisciplinary problem, that from there's just so many realms that from whatever your interests are, from, looking at the financial standpoint to the engineering standpoint to holding folks accountable to implementing it, where folks can really fit in. And I'm curious, Raya, what you've seen. You mentioned the building sector is a large chunk of where emissions come from statewide. What are the challenges that we are seeing with our building sector in getting those emissions down? Or Okay.
Yes, there are many, as you can imagine. And we're looking, first of all, is cost. What we're really talking about is big infrastructure, upgrades. And it's expensive and it's very, very challenging on many different levels. But even just for the scope of the challenge, we're looking at we're going to need a tenfold increase in technologies like heat pumps, and energy efficiency. And right now, and we understand that not all the technology we need is with us right now. So I just mentioned that in that investment in R&D, and supporting programs like, the ones that you are leading and participating in, are really important.
That's great. And for folks, I know we are running short on time, but for folks who are at home, how can they learn more about supporting efforts like this and maybe thinking more about just transition environmental justice?
Well, one thing, there's never been a more vibrant time for people of all stripes to get engaged in climate action. There is a roaring and healthy and vibrant movement in New York State and across the country. And I can provide some links. There's like the New York Renews Coalition and many other coalitions if you want to get involved. In fact, I think the Rochester March for Science is involved in New York Renews. I work with Eric Koski all the time. But one thing I will say that I think is really important is, if you want to sort of, just like we know that like the petrochemical industry, that there's this sort of like tussling of, needing to develop this science for industry and needing to sort of disrupt negative harm cycles. And so kind of being in community with some of the environmental justice advocates, for instance, a lot of the carbon capture and sequestration work is very controversial because some of it is considered greenwashing, also fueled by fossil fuels versus, things that may not be greenwashing. So I think as a scientist and an advocate, sort of checking in with movements, you don't have to agree with everybody all the time, but checking in so that you don't become kind of like anosmic or blind to, some of the pieces. It's difficult, but if we want to disrupt, we have to stay aware.
Yeah, I do want to mention, Raya mentioned right before we started recording that she also wrote the book on energy justice that's sitting right behind her. So I'm personally going to check it out. Yeah, but there's definitely, I think,
it's like, it is what it is. Thank you so much for mentioning it.
Of course. And any final thoughts from Miguel or Raya before we sign off for the day?
Yeah, no, I think this has been wonderful, and I think as Raya mentioned, like we all play a role on trying to come up with this solution, and like often it's really the small things, and like that subconsciously get into your routine that help us live more sustainably. There's going to be big changes that need to come from both policy and technology point of view, but we're going to need everybody to be engaged into these changes. So you do play a role in this too, and please get engaged.
I just love what you just said. It's so important. And what I think people don't always realize are like, what can I do? Literally, like having that mindset to be sort of having your mind open, understanding the issues. It really is step one, and it's important.
Awesome. I think the two of you said it best. So with that, we'll see you next time, and happy Earth Day, everyone.
Happy Earth Day, everyone.
Happy Earth Day. Bye.
Bye.